Hello friends, in today's class we will discuss about various concepts of acids and bases. So in this regard, many scientists worked on the various concepts and they gave various concepts regarding acids and bases. So we will see one by one their concepts. So first scientist who worked on acids and bases is Arrhenius. Arrhenius, and he proposed a theory called as Arrhenius theory. So according to Arrhenius theory, acids are the substances that dissociates in water to give hydrogen ions. Hydrogen ions are nothing but H plus ions. Okay, so acids are the substances. He explains that acids are the substances that dissociates into water to give hydrogen ions or H plus ions. So this is the definition of Arrhenius theory with regard to acids. Then coming to bases. Bases are the substances that produce hydroxyl ion. Means OH minus ion. So bases are the substances that produce hydroxyl ion or OH minus ions. So these are the definitions given by Arrhenius theory, and we will see the examples now. Take an example of hydrogen halide. So here HX. Take any hydrogen halide. When it reacts with water, it gives H3O plus OH. Sorry, it's my mistake. X minus ion. So halide ion. So when this, if it's mention the state of the reactants as well as products, it will be in the form of aqueous solution, it will be in liquid state, it is in aqueous form, it is in aqueous form. So if we discuss the substances which are acting as acids and which are acting as bases, here this one hydrogen halide is acting as an acid. Why? Because the substances dissociate in water to give hydrogen ions are called as acids. So as per the definition, this substance hydrogen halide is dissociating to form H plus ion and halide ion. So this is called as acid, and this is water is base in this reactant in this context. Then the hydronium ion, this is hydronium ion. Hydronium ion, and this is halide ion. So this is the example for formation of Arrhenius theory. Take another example. Second example. Metal hydroxide. When metal hydroxide dissociates, it forms metal positive cation plus hydroxyl ion. So here, if it is in aqueous state, this is also in aqueous state and this is also in aqueous state. Then metal hydroxide when dissociates to give metal cation and it gives hydroxyl ion. So this is the concept of Arrhenius theory given by Arrhenius. Then we will move to the next topic. Next scientist, that is Bronsted and Lowry. According to Bronsted and Lodey's theory, these acids are defined as the substances which can donate protons. So acids are the substances which donates H plus ions. And coming to base, so he defines bases as the substances which accepts H plus ions. So in short, we can write this as, in short form we can write this as acids can be proton donors and bases can be proton acceptors. Isn't it? So acids are always proton donors and bases are always proton acceptors. So we will see the examples for this theory. So if you see, observe the example of reacting of hydrochloric acid with ammonia. It gives ammonium ion, NH4 plus, and chloride ion. This is in aqueous state. This is in aqueous state. Aqueous, and this is also aqueous. So here what happens, as per the acid's definition, the substances which donate H plus ions. So here this hydrochloric acid is donating H plus ion, so this is acid, and ammonia is receiving H plus ion, so accepting H plus ion, so it is called as base. And after receiving H plus ion from hydrochloric acid, ammonia forms ammonium ion, so this is called as conjugate acid. This is called as conjugate acid, and after losing one H plus ion, it forms chloride ion, so this is conjugate base. This is forming conjugate base. So this is one of the example. We will see the next example. When HCl reacts with water, what it forms? It forms hydronium ion plus chloride ion. So here in this case also hydrogen chloride is donating one H plus ion to water molecule, so this is acting as acid and this is acting as base. Water is acting as base and forming hydronium ion, which is also called as conjugate acid, and hydrogen chloride ion, which is called as conjugate base. So this is about Bronsted acid and Bronsted bases. Okay, then so now we'll see about Lewis acids and bases. So in this Lewis acids and bases, the acids are the substances acids are the substances which accepts electron pair, and bases are the substances which donates electron pair. So here Lewis acids and bases, in Lewis acids and bases he is talking about only electron pairs. So let us see the example for this Lewis acids and bases. Take an example of sulfuric acid. So formation of sulfuric acid. If sulfur trioxide when reacts with water, it forms H2SO4. How it is forming? We will see. Sulfur is having 3 oxygens on 3 sides. So it is having lone pairs. Oxygen is having lone pairs, electron pairs. Then oxygen and hydrogens. For water molecule it is having 2 lone pairs. So among these 2 lone pairs, one lone pair is getting donated to sulfur to form sulfur trioxide. Sorry, it is sulfuric acid to form sulfuric acid in the form of this structure. Two lone pairs here, 2 lone pairs here, and as it is 6 lone, 3 lone pairs. So this is the structure of sulfuric acid. In this way, these concepts, this is acting as a Lewis acid, and this is donating low electron pair, so it is acting as a Lewis base. So this is sulfuric acid as it is. Take another example. It is forming so here it is acting as Lewis acid, and this is donating lone pair to this, so this is acting as Lewis base. So that's it regarding the acids, various concepts of acids and bases in this class.